Hi students, in this class we are going to see about excitons. These are the content of my topic. First, we will see the introduction of excitons. Then I will show you the formation of excitons and we will see the types of excitons. And then I will show you the use of excitons in electronics. And finally, I will summarize the topic. Exciton is the bound electron hole pair. So this bound electron hole pair which occurs due to the combination of electron in exciton energy level and the associated hole in valence band is known as exciton. So exciton என்னன்னா சிம்பிளா bound electron hole pair ன்னு சொல்லலாம். So இந்த bound electron hole pair எங்க நடக்கும்னா electrons exciton energy levelல இருக்கிற electronum valence band இருக்கிற ஹோலும் combined ஆகி exciton produce ஆகும். This is the basic definition of excitons. So this exciton is an electrically neutral quasi-particle and that exists in insulators, semiconductors and in some liquids. This bound electron hole pair as a whole is neutral and it will not contribute to any electrical conduction to the crystal, but it will transfer energy from one ion to the next ion. That is, it will not transport any electric charge, but it will transfer energy from one ion to next ion. Now let us see the formation of exciton. This is the valence band and this is the conduction band. Initially, the valence band is completely filled and the conduction band is empty at the ground state energy, and this is the forbidden energy gap. If we apply the photon energy, the electron absorb the external energy and move to the conduction band. And this is the basic. So if we apply the photon energy less than the energy gap, the electron will not go to the conduction band. So it will reach the excitons band. This exciton bands available below to the conduction band. An excited electron leaves holes in valence band. Now the electron in exciton band and holes in the valence attract to each other by electrostatic force of attraction and makes electron hole pair. This bound state of electrons and hole pair is known as excitons. I will repeat it once again. So this is valence band, this is conduction band, this is forbidden energy gap. So நம்ம photon energy இந்த forbidden energy gap விட கம்மியா நம்ம அப்ளை பண்ணும்போது electrons excited stateக்கு போகாம அதுக்கு கீழே இருக்கிற exciton லெவலுக்கு போகும். இந்த conduction bandக்கு கீழே இருக்கிற லெவலுக்கு பேரு தான் exciton bands ன்னு சொல்லுவோம். So இந்த இப்படி போற electrons ஒரு holes இந்த valence bandல create பண்ணும். So இந்த electrons bound electrons ன்னு சொல்லுவோம். இது free electrons இருந்துச்சுன்னா அது conduction bandக்கு போயிருக்கும். So இத bound electrons ன்னு சொல்லுவோம். இந்த bound electrons valence bandல இருக்கிற holes ஓட bound ஆகி இருக்கும் due to Coulomb force of attraction. So இந்த bound electron hole pair தான் நம்ம என்னன்னு சொல்றோம்னா exciton சொல்லுவோம். Now let us see the exciton formation in halides. So these are the examples of halides: calcium chloride, potassium chloride, sodium chloride, potassium iodide is the example of halides. In the case of halides, we have positive and negative ions. During the production of exciton, the electron has a negative ion and this negative ion transferred to the neighboring positive ion. So here we have positive and negative ion, so that the whole ion becomes neutral. Even after the removal of electron from the negative ion, it will not become a free electron. Instead of that, it will become bound electron and join next ion by joining through the lattice. So thus the electron does not contribute for electrical conduction. Now let us see the types of excitons. There are two types of excitons. One is weakly bound excitons. It is also called Mott-Wannier excitons. And another one is tightly bound excitons, that is called Frenkel excitons. First, we will see the weakly bound excitons. Weakly bound excitons, it is mainly observed in semiconductor. So here the electron hole interparticle distance is large compared to the lattice constant. We can see here this is hole, this is electron, this is lattice constant. So this distance, the electron hole, this is interparticle distance. It is large when compared to lattice constant. So that is R is the interparticle distance and A is the lattice constant. So R is greater than A. Cuprous oxide is the example for weakly bound excitons. These tightly bound excitons mainly observed in insulator. In this case, the electron hole interparticle distance is less than the atomic distance. This type of exciton, it is localized on or near a single atom, that is the hole will also exist in the same atom as that of an electron, although the pair may be anywhere in the crystal. So in this case, we have a smaller radius comparable to the size of the unit cell. Alkali halide crystals such as NaCl and KBr has tightly bound excitons. So in this case, we have smaller radius comparable to the size of the unit cell. So it is called tightly bound excitons. Next, let us see the use of excitons in electronics. Researchers have developed a new type of transistor based on excitons. So from this, the transistor can able to function at room temperature. So this excitons lead to new breed of faster, energy efficient and smaller electronics. I summarize my topic. In this class, we studied about excitons. This bound electron hole pair is called excitons. If we apply photon energy less than the forbidden energy gap, the electron released from valence band not become free electrons. So bound to the hole in the valence band by the Coulomb force of attraction. This excitons has two types. One is weakly bound excitons and another one is tightly bound excitons. Weakly bound excitons has a large radius. It can move freely throughout the atoms. Tightly bound exciton has a smaller radius comparable to the size of the unit cell. That's all. I hope you understand this class. We will see in the next class. Thank you.